a very important problem from mathematical expectation of one dimensional random variable. And the problem is given that variate x is normal 0 1. This is standard normal variate. Find the variance of e to the power x. Okay. So to solve this problem, we first use here the PDF of normal 0 1. That is the probability distribution of normal 0 1, and which is given by, if x is normal 0 1, then PDF generally it is written in the term phi of x. Phi of x, this is equal to 1 by root 2 pi e to the power minus x square by 2. The range is minus infinity less x less infinity. Okay, so we first write here x is normal 0 1. So PDF of x is given by phi of x, which is given by 1 by root 2 pi e to the power minus x square by 2 minus infinity less x less infinity. Okay, this is the PDF. Now we have to find the variance of e to the power x. Let y, this is equal to e to the power x. Now the definition of variance of any random variable phi of x is given by var of phi of x. This is expectation phi of x whole square minus expectation phi x whole square. Okay, so var of e to the power x, this is given by expectation e to the power x whole square minus expectation e to the power x whole square. That is expectation e to the power 2x minus expectation e to the power x whole square. Now we find out the value of expectation e to the power 2x and expectation e to the power x one by one. Okay, to find the value of expectation, we use the definition of expectation here. We write this is expectation phi of x, this is integration minus infinity to infinity phi of x into fx dx, where fx is the PDF. Okay, now expectation e to the power 2x, this is given by integration minus infinity to infinity e to the power 2x, and here we know that fx means phi x, so we write 1 by root 2 pi e to the power minus x square by 2 dx. Okay, now 1 by root 2 pi into integration minus infinity to infinity e to the power minus x square by 2 plus 2x dx. Okay, and this is 1 by root 2 pi integration minus infinity to infinity, and e to the power minus half, we take common here, x square minus 4x plus, we get plus 4, and we here write minus 4 to balance plus 4. Okay, and this is 1 by root 2 pi integration minus infinity to infinity, and this is e to the power minus half into x minus 2 whole square, and another term is e to the power minus half into minus 4, so this is e square dx. Okay, now for any type of PDF, we know that integration minus infinity to infinity fx dx for continuous random variable, this is 1. This is an important property of PDF. We use this property here. We first write e to the power 2 outside of the integration e to the power 2, and integration minus infinity to infinity 1 by root 2 pi, and this is e to the power minus half into x minus 2 by 1 whole square dx. Okay, we write here another 1, and clear that this function is like 1 by root 2 pi sigma e to the power minus half into x minus m by sigma whole square. Okay, and this is nothing but this is the PDF of normal m sigma, and the integration of this fx we already say here, this is 1. So this is nothing but this is normal 2, 1. This is m and this is 1, right? So we get the integral value of this term is 1, okay, by using this property of PDF. So we get e square from here. So we find the value of expectation of e to the power 2x. This is e square, okay. Now we have to find the value of again expectation e to the power x, and clearly this is given by integration minus infinity to infinity e to the power x 1 by root 2 pi e to the power minus x square by 2 dx. In similar manner we write this result, and now we write that integration minus infinity to infinity 1 by root 2 pi e to the power minus half into x square minus 2x plus 1 minus 1, and this is dx, okay. So we get from e to the power minus half into minus 1, so this is e to the power half. We write it outside the integration, e to the power half integration minus infinity to infinity 1 by root 2 pi e to the power minus, this is half into x minus 1 by 1 whole square, and we write here another 1, and this is dx. And by using this similar argument, this is nothing but normal 1 1 distribution, because m is 1 and sigma is 1, so this is e to the power half into 1, so we get root e, okay. Now we put two value. This value is expectation e to the power x, and this value is expectation e to the power 2x, is given by e square and e to the power half. We put here, we get the result, that is the variance of e to the power x, which is given by e square minus e to the power half whole square, that is e square minus e, that is e into e minus 1, okay. This is our result. Very simple problem. We solve this result by direct method, okay, and we solve this type of problem by another method. So we start the another method here, okay, but we say before starting this method, it is easier than the last method we use after that, okay. We solve this problem in another method, because in another method we get an important probability distribution which is log normal distribution. For this reason we solve this problem in another method. In this method we first find out the probability distribution of y, which is taken as e to the power x, okay. So to convert the PDF of x to PDF of y, we use the transformation of random variable, this formula, which is given by g of y, this is equal to fx into mod dx dy, where y this is equal to phi of x, and for this we must have two important property. The first property is phi x is differentiable and phi dash x is the same sign, okay. We use this property. Now in real variable we write y this is equal to e to the power x, and getting the value dy dx, this is e to the power x, and clearly this is greater than 0 for all x belongs to minus infinity to infinity, okay, because here range is minus infinity to infinity for normal 0 1. So this is differentiable and also it keeps constant sign. So we first find the PDF of y, hence PDF of y is given by g of y, this is equal to phi of x into mod of dx dy, okay. So phi of x is 1 by root 2 pi e to the power minus x square by 2 into dx dy. This means e to the power minus x, because this is dy dx, and clearly the ranges, we find the range here. We know that for all value of x, that is minus infinity to infinity, e to the power x varies from this is 0, this is infinity, because e to the power minus infinity, this is 0, and e to the power infinity, this is infinity. So the range of y 0 less y less infinity. Okay, and we first transfer x to y because this is the PDF of y. Now PDF of y is given by, we put e to the power x, this is equal to y, so e to the power minus x, this is equal to 1 by y, so we get 1 by y into root 2 pi e to the power minus half into log y whole square. This is 0 less y less infinity, right? And this is nothing but log normal distribution. Clearly it is same as this. This is 1 by x into root 2 pi e to the power minus log x whole square by 2, and the range 0 to infinity. Okay, so we get the distribution of y. Now we have to find var y, because we have to find the variance of e to the power x, that is variance of y. So we have to find expectation y square minus expectation y whole square. Okay, now to find the value of expectation y square, and using the definition of expectation, we get this is integration 0 to infinity, this is y square into 1 by y into root 2 pi e to the power minus half log y dy. We directly put the range 0 to infinity because in the other side this is 0. Okay, and this is obviously square. Here y and y cancel out, so we get 0 to infinity y by root 2 pi e to the power minus half into log y whole square dy. Okay, now we integrate this term or this integration. To integrate this type of integration, we put first log y, this is equal to z. Okay, then we get 1 by y dy, this is equal to dz. This gives, this is dy equal to y dz. Okay, and clearly the range of z is minus infinity to infinity, because we know that if y tends to 0 plus, then z, this is log y, this is tends to minus infinity, and y tends to infinity, log y, this is tends to infinity. So range again minus infinity to infinity, and we get 1 by root 2 pi and e to the power minus z square by 2. And here a y present, so y dz and y, this is y square dz. Okay, and y square means here we get, this is y equal to e to the power z, so y square equal to e to the power 2z. So we put directly here e to the power 2z dz. Okay, and we say that this integration we get here, this is the previous one. We already solved this type of integration in the first method. So we directly write the result here, this is e to the power 2. Okay, and in similar manner, if we find expectation y, then we get also here the same type of integration as the previous method, and this is also e to the power half. Okay, so we put the value of e to the power y square and expectation y square and expectation y here, we get the value of var y, this is e square minus e to the power half whole square, this is e square minus e, this is e into e minus 1. Okay, very important problem related to normal 0-1 distribution and log normal distribution. And here also we use the transformation of random variable. Thank you for watching.